Hi guys, good evening. Can you hear me? Hello. Can you hear me?
Good evening, sir. Yes, sir.
Yeah, thank you. So let us start session. So last class. Last class about just basics started previous class. See, this introduction to software, about system software, about application software discussed. Yes, basics like about bias discussed, about what is OS discussed. Okay, next about front end, back end discussed. Exactly Java. Yes, we're using here discussed. Next language package discussed here. Next about low level, high level languages. This topic discussed here. Okay, generation of computers. This also discussed here. About high level, low level, high level language. These points also discussed here. Okay. So next yesterday's class about interpreter and compiler discussed. What is interpreter? What is compiler? Differences discussed. Next Java. Java depends on both compiler as well interpreter. Java both. See here. These are interpreter based language. Interpreter. These are interpreter based language. Next compiler. These are compilers. C, C++, dot. They are compiler. They are interpreter based. Okay, but when it comes to Java, both Java depending on both compiler as well interpreter both here. Compiler, interpreter. Java depends on both. So Java introduction. So yesterday Java introduction discussed here. How Java program is working. Yes. First error checking by the compiler. Okay. Yes, Java. Yes, source code converts in byte code to binary code, then processor finally output, right? Source code to byte code, this part by the Java compiler. Next, byte code to binary code, this part by the Java interpreter. Right? So two things involving in Java here. Compiler and interpreter. Compiler and interpreter. Compiler and interpreter. Okay. So these topics practically we discuss in Java programming. Once enter into Java programming, how Java compiler is working, how interpreter is working. We again will discuss. Again we'll discuss about Java compiler, about Java interpreter. Again we'll discuss. Okay, right? Yes, right. Yes. Now today let us start Java features here. See, yes, your match. Yes, 7:30 p.m. See, day two. On day two, Java history discussed, right? Java history. Yes, about Java, Java history, Java features, and all that discussed, right? See, first version of Java released with these features like independent platform, portability, whoop language, scalability, security, right? They are Java features. Yes, to understand all these features here, to understand Java features here, yes, some software basics discussed. Yes, to understand Java features, I have explained about software basics like system software, next application software, next about OS discussed here, about OS, next about low level languages, high level languages, low level, high level languages. Okay, next about interpreter compiler. So these things, yes, Java, yes, based on compiled as well interpreter. So all these basics discussed. Now we can understand Java features. Now we can understand Java features here. So these are the Java features. In this first one, independent of platform. Let us see about independent of platform. About independent of platform. Yes, independent of platform. See, Java is an independent of platform. What does it mean? See, what does it mean? What does it mean here? So here platform means what? Platform means it's a OS. Platform means operating system. Platform means it's an operating system. Platform means it's an operating system, right? See, previous class we have discussed about OS. Some idea about OS. Introduction about OS discussed. See, operating system. See, OS, right? OS. Hardware. Yes, hardware on top of hardware, OS running. On top of OS, all the programs running like C, C++, Java, Hadoop, database, all the programs running. Right? Hardware, on top of hardware, there is a OS running. On top of OS, all the programs running, right? So OS like a platform. On top of OS, all are running. Maybe C program, C++, Java, Hadoop, all are running on top of OS. So OS it's a platform. On top of it, all are running. It's giving platform. So OS is a platform. See previous class we have discussed about this point, right? It's a platform. So what is operating system means? It's a platform. It's a platform where we can run all the application software. It's a platform where we can run all the application software. Okay, it's a platform where we can run all the applications also. All the softwares running on top of OS. Okay, right? See, inside of OS, there is a library. Library. So these programs, first of all, linking with OS library, then communicates with hardware components. So you're happening through the OS library here. Library. That library contains some input output functions. OS library contains input output functions to perform IO operations. So this point previous class we discussed. Every program has to link with OS library before going to run. So these programs, C program or Java program, Hadoop, whatever it is, all the programs first of all linking with OS library, of linking with OS library and execution. So while linking with OS library to communicate with hardware components. See these programs directly cannot communicate with hardware. So between this program and hard, there's a OS library. With the help of library communicating with hardware components. Okay, linking with OS library. That link may be statical linking or dynamical linking. Yes, today we'll discuss. Okay, statically, dynamically. Suppose C and C++ statical linking. Java and Python is dynamical linking. Static linking, dynamic linking. Today we'll discuss. Okay, now here, see, Java is an independent platform. What does it mean? Here, platform means operating system. Platform means OS. Platform means OS. Independent of platform means independent of operating system. Independent of platform. Platform means independent of platform means Java program can run on any OS. Java program can run on any OS. Independent of platform means independent independent of platform means Java program can run on any OS. Java program can run on any OS. Java program can run on any OS. That's the meaning of independent of platform. Independent of platform. Independent of platform means Java program can run on any OS. No question is here. Question is how Java is made us independent of platform. That is question. Independent of platform. Independent of platform. How Java made us independent of platform. Let us see about it. Interesting topic. Interesting topic. How Java made us independent of platform. So how Java made us independent of platform? Let us see about it. How Java made us independent of platform. Yes, to understand about it. 1 second. Just a minute. Just a minute. Yes, some students are connecting. Just a minute. They're asking for some link. Yes. Now here question is how Java made us independent of platform. Yes, to answer this one here. Yes, you must have the exe file. Yes, to understand about it. Yes. To understand about it, yes, you must have the exe file and dot class file knowledge. Yes, C program exe file, Java is a dot class. Yes, you must have the exe file knowledge. Dot exe. Exe means executable file. Dot class file. Yes, you must have this knowledge. Yes, let us see about what is exe file, what is dot class file. So what is exe file, what is dot class? Let us say about exe. First of all, about exe file. About exe file. About exe file. About exe file. See some question for you is some question. Suppose exe file prepared. Exe file prepared on Windows OS. Exe file prepared on Windows OS. Can I run on Linux OS? That is question. Anyone can you answer this? Anyone idea about it? Yes, of course I'll explain. Of course I'll explain. Exe file prepared on Windows OS. Can I run on Linux? There's a question here. Anyone can you answer this? Yes. Question is here. Exe file prepared on Windows OS. Can I run on Linux OS? Hello. Hello. Muskan, yeah, this 7:30 p.m. Can you send me that paid email list? Yeah. Please send it. I have to share the software today further. Okay. 4 or 5. I think today 2 members have been paid. I think. Okay, check it. Check it and share me. Okay, send me all that emails. Okay. Yeah. Yeah. So exe file prepared on Windows base. Can I run on Linux base? Answer is no. Answer is no. Reason. What's the reason here? So what's the reason? Why? Reason? Yes. Reason exe file. Exe file is an who is dependent. Exe file is an who is dependent. Exe file is an who is dependent. Reason. See exe file prepared on Windows base. Can I run on Linux base? Answer no. Answer no. Reason exe file is a OS dependent. Now immediately question why exe file? Why exe file is OS dependent? OS dependent. Okay, these are some interview questions, fresher questions. Okay, not only fresher, even in experienced staffs will get this. How Java made us independent platform? Yes, how Java made us independent platform? That answer. So for that about exe file, about dot as well. So first of all about exe file. So exe file prepared in this way, can I run a Linux base? No, reason exe file is an OS dependent. So why exe file is OS dependent? So why exe file is OS dependent? Just to answer this, you must have exe file knowledge here. What is exact exe file? So exe file contains what? Exe file. So exe file contains what? Let us say about exe file. See, actually here exe file is a binary code file. Exe file is a binary code file. Exe file is a binary code file. Okay, exe file is a binary code file. Yes, it is a system understandable language. System understandable language. System understandable. Understandable language. It's a system understandable language. It's a system understandable language. Okay, exe file is a binary code file. It's a binary code means like zeros ones format. Binary codes zeros ones format. It's a system understandable language. Okay, so exe file is a binary code file. Yes, it's a system understandable language. It's a system understandable language. Okay, suppose for example here, so let us take C program exe file. For example here, yes, C program exe file prepared on Windows OS. Then it contains what? Then it contains what? Let us see. C program exe file prepared on Windows OS. Then it contains what? Let us see about it. C program exe file prepared and Windows based, then it contains what? Let's see about it. C program. Let me show the C program. Here this is C program, Windows based C program. It's a Windows based C program. Okay. See, what is our topic? Yes. What is topic here? Yes, C program exe file prepared and Windows based. Windows based. So this is Windows based C language. Windows based C language. Okay. Yeah, this is C program. Okay. C program. C program code is like this. A equal to B equal to C into C like this, right? Yes, how the C program is working. First, the C program compilation, right? Yes, success, no errors. If no errors, running. Yes, got it right. See here this program. Let me show this program 1 second here. A equal to 10, B equal to 20 here. Yes, into C. C equal to A plus B. So addition. A plus B 10 plus 20, 30 output. Addition 30. Subtraction minus 10. Yes, multiplication 10 into 20. It's a 200. 200. Right now compile. No error. Success. Now run it. Yes. Addition, subtraction, and multiplication. Right. Yes, then completed. Now what happens here? Let us see. What is happening back end of this function? Let us see back end. What is happening behind of this function? Behind of this, what is happening? It's a math.cpp. This program is math.cpp. Let us go to here. Yes, C drive. This is a turbo C, TC. Yes, bin. Here this is a math.cpp. Math. See, this is a file here. Math.cpp. 1 second. Let me delete all that old. There are some old files. So see, math.cpp. So this is right. CPP or C language both are same. CPP and C language both are same here. CPP means C++. Now here, first compile. Let us compile. First compile. We should compile the C program. When compiled, what happens here? See this. Yes. So math.obj file generated. So here this is right. Math. Yes, object file properties. See this dot obj. That object file generated. So what is this object file exactly here? Math.obj, that object file generated. What is exactly object file here? See, C compiler converts this whole code into binary formats. C compiler converts this code into binary code and write to math.obj file. So this math.obj object file, this contains binary code for C program. Yes, is C program, right? Yes, all these codes, this binary code, this code, source code, C program code converts into binary formats. So this code converts into binary format. This code converts into binary format and write to yes that object file. Okay, right? Yes. After this, next compiling. Compile. When I compile, what happened here? Yes, math.to be generated. Now run it. Yes, run it. When I run this here, what happens? Exe file generates, right? Run it. See, yesterday same discussed. Run it here. See, .exe file. Yesterday discussed same point. Now .exe file created. So what happens here? C compiler. First of all, it creates one exe file. After that execution here. Okay, it creates exe file. A compiler generates exe file. After generating exe file, then executing it. What happens here? Compiler. So first compiler checking for all errors. Success. No errors. See compile. Compile. Success. No errors. If no errors, suppose if you are running here, now it creates exe file. So first of all, compiler checking for all the errors. If no errors, then it creates one exe file and executes. Creates exe file, executes. See this. That exe file created here. Math.exe file created. Math.exe file created. See .exe file created. Now this exe file contains what? Let us see about exe file. Okay. Yes. Now here topic. Yes. C program exe file prepared. C program exe file prepared on Windows OS. Then it contains what here? Yes. For this, yes, binary codes. Yes, binary codes. Binary codes. Binary code for C program. Binary code for C program plus so binary code for C program. That means here that math.obj file. Yes, this math.to this contains binary code for C program plus next here. Yes, std data set of it's a predefined library. Std data is conjugate data. These are predefined library. These libraries also having some binary codes. So this binary code plus C program binary code, linking these things here. See binary code for C program plus binary codes, binary codes for C library, binary code for C library, plus binary code for OS library, binary code for OS library, binary code for OS library. So by linking all of these generates exe file. C compiler first of all generating exe file. See when you run this program, so first of all creates one exe file. Let me show once again here. See exe file backend exe file here dot exe file. 7:54 p.m. exe file created. Now again run it. When I run it here, see run it. Yes, executed. Now exe file created. See that exe file created. Okay, see compile. Yes, success. Yes, after compilation, now run it. See this. The timestamp changes 7:57 p.m. Just now exe file created and executed. So how that exe file creating here? C compiler takes the binary code of your C program. That means math.obj file. Math.obj file plus it will take binary code for C library. std data is connected. Binary code for C library plus binary code for OS library. Binary code for OS library. See this is OS. Inside of it is library. Windows OS, Windows library. Windows OS library. So taking all of things and generating exe file. Finally here, okay, C program exe file prepared on Windows OS. Then it contains binary code for C program plus binary code for C library plus binary code for yes Windows OS. Now it's a Windows OS. Windows OS library. Windows OS library. Windows OS library. Windows OS library. By linking all of these, it generates exe. That is exe file exactly here. That is exe file. Let us take one more example. Yes, C program exe file prepared on Linux based. Let us see about Linux based. On Linux based, C program exe file prepared on Linux based. Then it contains what here? Binary code for C program, binary code for C library, and binary code for Linux based library. By linking all of these, generating exe file. See at the beginning, previous class we discussed. See, every program has to link with OS library before going to run here. Every program has to link with OS library. Okay, now C program linking with OS library. If it is Windows OS, links to Windows OS library. Suppose if it is Linux OS, links to Linux OS library. Binary code for C program, binary code for C library, binary code for Linux OS library. By linking all of these, it generates exe file. Let me show on Linux OS also. Linux OS. Let us see Linux OS. Linux OS. Yes, demo is a Linux login, like a Windows login, Linux login. Like a Windows based Linux based also is a login process. Login. Yes. Open terminal. Yes. PWD means present working directory. LS its contents. Okay. Yes. See, our topic is not about Linux commands. Our topic about exe file. C program exe file. Okay. CD change of directory to. Okay. Let me create some directory. Make directory. Command row. Directory created. So presently working direct demo ls in this mnraw directory created. Now cd change of directory, cd mnraw changed. So presently working directly mnraw ls nothing. Here I'm developing simple C program, very simple C program here. Okay, gedit test.c, test.c, test.c. So hash includes stdio.h, hash include stdio.h. Next void main function starting ending. So void main function starting ending. Okay, yes, here int a is equal to 10. Next int b is equal to, yes, 20. So int a is the same previous example, same like a Windows example, same addition, subtraction, multiplication of two numbers, same Linux I'm writing here. Okay, next int c, int variable c, right? Now here c is equal to a plus b, a plus b, c equal to a plus b, a plus b, right? Now printf, yes, addition is equal to %d slash n comma c, displaying the result value c here, right? C equal to a plus b. Okay, next c equal to a minus b, c equal to a into b, c equal to a minus b. Okay, subtraction. Okay, yes, next c equal to a into b, c equal to a into b. Next here multiplication. So this is C program, simple C program. So this is C program code. Next stdio.h header file. See this here also header file is having some binary code. This is having some binary codes. Now close it here. ls. See, now it should compile like a Windows OS. Here also compilation. Yes, see Windows OS here. See all C compilation, right? Backend happens. Something happens here. Backend. Suppose if I run it here, yes, backend exe file creates and executing. Okay, Windows here Turbo C, behind of Turbo C everything happens. But when come to Linux here, yes, you have to do everything manually here. Manually compilation. Yes, how to compile? CC means C language compiler. Hyphen C means only compile option. Test.c, compiled, no error. C test.o file generated, right? Test dot, what is .to file? It's object file, same like a Windows file. Windows file math.obj. Yes, Windows OS here also object file created. Okay, here also object file created. So what is this object file? Test.o. Test.o contains what? Binary code for C program. Yes, for this whole code converts in binary format. Compiler, this whole code converts in binary format. Binary format right into test.o. Test. So this test.o contains what? Binary code for C program. Okay. After that, now we should create exe file. Creation of exe file. cc hyphen o. Suppose exe name is, let us say project is a exe name. Project then test.o. So this test.o, right? Now cc C language compiler linking all the object files, linking and generating exe file. Linking all of it, generating exe file. Okay, now project is exe file, right? Linking. Now linking what here? See this. Yes, C program exe file prepared on Linux base. Then it contains what here? Binary code for C program. That means test.o file. This test.o file binary code for C program. Okay. So binary code for C program test.o file plus binary code for C library. C library means that stdio data setter file. Okay. See. So here binary code for C program means this part. This part converts into binary format. That binary format instead of test.o plus binary code for C library, stdio etc. for library here. Binary code for this. Binary code for C program plus binary code for this library plus binary code for OS library here. Binary code for Linux OS library. Okay. See, previously we discussed. See, every program has to link with OS library. Now okay, OS type linking here, right? Here is linking. Yes, if it is Windows OS, links to Windows OS library. If it is Linux OS, links to Linux OS library. If it is Unix OS, links to Unix OS library here. That links to OS library. Okay, linking. Of linking generated exe file. Project exe file. Right? Now let us run this project exe file. Yes, is addition, subtraction, multiplication. This project is exe file. This project exe file contains what? Binary code for C program, binary code for C library, plus binary code for OS library. By linking all of this generates exe file. So this is exe file Linux. Okay, it? Yes. Now let us run it project. Yes, executed. We got the output here. Addition, subtraction, multiplication. Okay. Yes, let us see what are the contents of project exe file. Let us see the contents of exe. It project. Let me show the contents. I'm opening that exe file. So what is exe file? Exe file contains what? Binary code. Exe file contains completely binary code. Exe file contains binary. See, this is a binary code, machine language. It's exe file. It's a machine language. It's a machine language. It's exe file. It's exe file. Next, one more thing here. Linux, there is a file command to check the type of the file. Linux is a file command to check the file type. File. Suppose I'm checking what's the type of test.c. Test.c. See file command checking test.c. Now it is saying that test.c is C source ASCII text. C source program is ASCII text. Okay, now file. Let us check project or project that name can. Yes, is exe file. Let's see, run it. Now see this file command checking what's the type of this project here. Yes, it's a executable file. Project is a executable file. Next in this, see this Linux. Okay, so Linux base this is see Linux x86. Okay, dot yes for it. What is this one here? What is this one here? See ld hyphen Linux x86 dot s42. It's a Linux OS library. That means that project exe file is linked with Linux OS library. So like dot so is a OS library. It's extension for OS library. So Linux OS library linked to project exe file. See, actually, see all these embedded C concepts. Simply just a Java trainer, you can't explain all of these things. Okay, only real-time person can explain all of this. Who is having embedded C knowledge also can explain all this here. Okay, so that project exe file, yes, it's an executable file that can see this Linux OS library. Okay, yes, if exe file, see, if exe file prepared in this way that links with Windows OS library. Suppose exe file prepared a Linux OS linking with Linux OS library. Yes, let us take one more example. One more example. One more example. Suppose C++ program. Now let us take C++. C++ program exe file prepared on Windows OS. Windows OS. Windows OS. Windows OS. Then it contains binary code for C++ program plus binary code for C++ library. C++ also there is a library here. Next binary code for yes Windows OS library. Windows yes Windows OS library here. Windows OS that is complete exe file. Okay. Yes. C++ program exe file prepared in Windows OS. Then it contains C binary code for C++ program, binary code for C++ library, binary code for OS library, Windows OS library. By linking all of this generates exe file. That is exe file. Now, what is common in all the cases? Three cases. exe, C program exe on Windows OS, C program exe on Linux OS, C++ program exe on Windows OS. What is common here? All the cases? Yes. See, all the cases linking with OS library. All the cases linking with OS library. All the cases linking with OS library. That is what is happening here. Exe file always linking with OS library. Here common points. Yes, exe file. Yes, exe file always. Okay. Yes, always. Exe file always linking with OS library. That is happening in all the cases. Exe file always linking with OS library. Okay, one second. Let me have some water. Yes, what is happening commonly here? Common thing that exe file. See, exe file always linking with OS library. Okay, exe file always linking with OS library. That is common point. Okay, right? Yes, here. So, for example, test.exe file prepared. Yes, test.exe file prepared on Windows page. Windows page. Then it links. Then it links with Win library. Win library links with Win library. That's like a fine. So test.exe file with Win library with Win library with Win library working on different platforms. Working on different platforms. Or operations. Let's say about different platforms. How it's working on different platforms here. Let us see about it. See, tested.exe is about tested.exe file prepared on Windows OS. Then it links with Windows OS library. Yes, test.exe file with Win library. Win library working on different platforms. Let us see. Different platforms. Let us take different platforms here. Okay. So different platforms. See, here there is a hardware. Yes, there is a hardware. See, on top of hardware, on top of hardware, yes, Windows OS. First, let us take Windows platform. Yes, Windows OS with Win library, Windows OS with Win library. So Win library, Windows OS with Win library. Okay, Windows OS Win library, right? Next, see, on top of which C program running. Yes, on top of which, yes, test.exe file is running. Test.exe. Yes. See, so hardware, on top of hardware, this is a Windows OS with Windows library here, right? So when you try to run test.exe file with Win library, test.exe file with Win library. Okay. So this one, when you try to run on Windows OS here, now test.exe file, yes, it will try to call Win library. It will try to call Win library. Windows OS library. Yes, here it's available. See, system is Windows OS. Platform is Windows platform. On top of Windows OS, test.exe file is running. Here that exe file test.exe file with Win library already linked with Windows OS library. So linked with Windows OS library. Since linked with Windows OS library, it makes a call to Win library. Since test.exe file linked with Windows OS library, then call to Windows OS library. Yes, yeah, available. So simply test.exe file, just it makes a call to Win library. Okay, already available. So with the help of this communicates with hardware components, so successfully executing. Fine. Now let us take another platform. Another platform, Linux platform. Linux base. Let us take Linux base. Linux base with the Linux library. Linux base with Linux library. Linux base with Linux library. Yes, how it's working here. Same exe file, if you try to run a Linux base, what happens here? Same exe file. Yes, if you're running a Linux base here. Now this test.exe, you will try to call Win library, but here is not available. This library is Linux library. So exe file is linked with Windows OS library. Since linked with Windows library, it will try to call Windows library, but here it's not available. Okay, it's not available. So exe file library is Windows library, but current base library is Linux library. So this library is not matching, simply fails. Simply it fails here. It won't work. Okay, so exe file prepared on Windows OS running on only Windows OS because that links with Windows OS library. It won't work on Linux OS because the library is not matching. So exe file is OS dependent. Let us take another platform here. Suppose Mac OS with Mac library. Okay, see test.exe file. Yes, when you try to run here also, it will try to call the Windows Files library, but here is not available. See that link, once link that is fixed. Okay, so once link that is fixed here. See test.exe file prepared Windows Files. It links with Windows Files library. Link is fixed. Link is fixed. Okay, voice lab link is fixed. The link is fixed here. That link never changes. Link fixed here. So when you try to run on Windows base, yes, it's working because that library matching. Same exe file if you're running a Linux base, it fails because that library is not matching. Same exe file if you try to run Mac base, again fails because yes, that link not changing. It's a fixed link. This is called statical linking. Statical linking. Okay, yes. See exe file statically links with OS library okay, exe file statically links with OS library. Statically means fixed. Statically means it's a fixed. That link is fixed here. Statically fixed. Okay, yes, since exe file statically linked with OS library, yes, library, yes, it's a OS dependent. Okay, since exe file statically means link is fixed, that link will not change. Always with same library. Link will not change, so it fails in here. Since exe file statically linked with OS library here, yes, it's a OS dependent. It's a OS dependent here, or platform dependent. It's a OS dependent resources. So they about exe file. So why exe file is OS dependent? Yes, simply answer why exe file is OS dependent. So why exe file is OS dependent? For this answer, yes, exe file statically linking with OS library. Since linking with OS library here, yes, it's a OS dependent. That's the reason here. Now let us say about dot class file. Okay, about exe file OS dependent. Now dot class is independent, right? Independent of OS. How? How dot class file? Now question is how dot class file? See, exe file is a OS dependent, that is cleared. Okay, right? Exe file, yes, is an OS dependent. It's cleared. It's clear, right? It's clear. Now dot class file. See, dot class file is an independent platform. Dot class file is an independent platform. Independent, 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 independent platform. Independent platform. Independent platform. Platform or OS. Anyone you can see independent of OS. How? Yes. How Java made us independent of flat? Let us see here. Dot class. Now about dot class file. See, dot class file is an independent of platform. Yes. How? How it's made us independent of platform. Now about dot class file. Now we should know about dot class file. What is dot class file? About dot class file. Let us say about dot class file. See about dot class file. Same example I am taking here. Example. Similar kind of example. Dot class file. Dot class file. For example here. Yes. Java program. Java program. Yes, in case of exe is a dot class file. Java program dot class file prepared on Windows OS. Then it contains what? Binary code, not binary code here, byte code. After comparison result is byte code, not binary code. After comparison result is byte code. So byte code. Byte code for Java program. Byte code for Java program. Next, byte code for Java library. Java is a library here. Byte code for Java library. Byte code. Byte code for Java library. Byte code for Java library. So Java library is like java.lang package, Java type of package. There are some packages, nothing but library. Like a C language in Java, there is a library here. Okay. So bytecode for Java program, bytecode for Java library plus binary code for OS library. No, don't have this part. Okay, simply dot class file. That dot class file contains only bytecode for Java program, bytecode for Java library. See, Java library also developed in Java here. Java library also developed in Java. C language developed in C library. C library developed in C language. C++ library in C++. Python library in Python. Like that, Java library developed in Java here. So Java library also Java program. That means here. So here, so dot class file contains what? Bytecode for Java program. Bytecode for Java library. Java library also Java program. That means it's a pure Java program. So dot here dot class file here dot class file dot class file dot class file is a pure Java program, Java program in byte format, byte format, byte format. So dot class file. See, dot class file is a pure Java program. Dot class file is a pure Java program byte format here. Bytecode format, bytecode format, bytecode format. Okay, Java dot class was a pure Java program bytecode format. Okay, yes, you don't have. See, you don't have. Yes, you don't have any voice library. You don't have any voice library. Okay, don't have any voice library here. Okay, so dot class file is a pure Java program in bytecode format, bytecode format, bytecode format. Okay, don't have any voice library here. Okay, see, suppose exe file, if it is exe file, links with voice library, but dot class file never linking with voice library. So dot class file you don't have any voice dot class file don't have any voice library. Dot class file is a pure Java program bytecode format. It don't have any voice library. Okay, fine. Okay, fine. Okay, suppose tested dot class file, tested dot class file prepared. Yes, prepared on anyways, on anyways. Okay, tested dot class file. Suppose, for example, tested dot class file prepared anyways here. Yes, anyways, but don't have anyways library. But don't have anyways library. Anyways library. Yes, no OS library. It's a free from OS library here. So dot class file is free from OS library here. Dot class file. So dot class file, yes, free from OS library. Free from yes OS library. Dot class file don't have any OS library here. So dot class file free from OS library. It's a free from OS library. Okay, right? Now let us see. So tested dot class file. Okay, running on yes, working on different platforms like exe file, working on different platforms, working on different platforms, different platforms, different platforms. Okay, see tested dot class file working on different platforms. How it's working? Yes, like C language example, like exe file example. Let us take Java also, different platforms, different platform. First Windows platform. So dot class file running on Windows platform. See, dot class file working on different platforms. Let us take Windows platform here. Hardware on top of hard this Windows OS with Win library. Now it's a dot class file. So dot class file. Now dot class file, right? Now this dot class file. Can I run it directly or not? Now this dot class file, can I run it here? See, previously we have discussed. See, every program has to link with OS level before running. Maybe C program or Java program, Python. All programs have to link with OS library. It's compulsory. It has to link with OS library. Okay. Even this tested dot class file also has to link with OS library, but not linked. It's not linked. Suppose if it is exe file, what happens here? See, in case of exe file, say at the time of creation of exe file itself, exe file always linking with OS library. Okay, at the time of creation of exe file itself, linking with OS library. So already linked. So prepare that is already linked. But Java program, yes, is not linked here. Java program is dot class file is a free from OS library here. Okay. Now get to run the dot class, but it has to link with OS library. Even Java program also has to link with OS library, but not linked. What happens? Will it run? No, it won't run. See, this dot class file also has to link with OS library, otherwise cannot run. Otherwise cannot run here, but not linked here. So it won't run directly here. So this dot class file won't run directly. This dot class file won't run directly. Yes, it has to link with Windows OS library compulsory. It has to link. This dot class file has to link with Windows OS library. It's not linked. So first of all, this dot class file linking with OS library, then execution. Who will link it here? Dot class file not linked. Then who will link it here? To link this between tested dot class file, between dot class file, Windows OS, one more layer come to the picture. So between dot class file, see, between dot class file, Windows OS, there's one more layer come to picture. What is that layer? Anyone can you guess it? Yes, good. Santosh, good. Here it says JVM. Now JVM will come to picture. JVM come to picture. JVM means Java Virtual Machine. JVM means Java Virtual Machine. Java Virtual Machine. Now Java Virtual Machine taking dot class file. Java Virtual Machine taking dot class file and links with Windows OS library. Once linked here, executes and communicates with hardware components. So here JVM takes care of linking dot class file with Windows OS library. Right? Once linked here, execute generating output here. Now let us take another platform. Let us take another platform. Another platform. Yes, like Windows OS. Let us take Linux OS. Linux OS. Linux OS with the Linux library. Now here also same thing happening here. So Linux OS. On Linux OS this JVM. See, Windows OS having its own JVM. So Windows JVM links tested.class to Windows OS library. Now Linux OS having its own JVM. That Linux OS JVM, Linux JVM taking .class file, linking with taking .class file, linking with Linux OS library here. Taking .class file links with Linux OS library here. Okay, right? Yes, suppose again OS change. So Mac OS, for example, Mac OS with the Mac library, Mac OS with Mac library, Mac OS with Mac library. Okay, right? Mac OS with Mac. So here also JVM can. So Mac with this JVM taking .class file, yes, link with Mac library. That means same program file, tested.class file, tested.class, same program file running on different platforms. Same file running on different platforms here. So every time of changing that OS here, that link changing. Every time of changing OS, that link changing. Every time of changing OS, that link changing, right? Runtime link changes. That is nothing but dynamic linking. Link is changing. It's a dynamic linking. When come to C programming, exe file, it's a static linking. Okay, exe file. See this exe file is a static linking. That link never changes. See exe file static links OS library here. Static link is fixed. So that link never changes. Exe file. So exe file. So exe file is static linking. Okay, that link is fixed. That OS library link is fixed. That link never changes. But Java, what happens here? Every time of changing OS, that library, yes, link changes. Every time of changing OS. Suppose if you're running on Windows OS, links to Windows OS library. Same program, if it is running on Linux OS, links to Linux OS library. If it is running on Mac OS, links to Mac. Suppose Unix OS, links to Unix here. So every time of changing OS, that link changes. Okay. See, for every time. See, every time of changing OS, every time of changing OS, link changes. Link changes. Link changes. Yes, it is called dynamic linking. Yes, it is called as dynamically linking. Dynamically linking here. Dynamically linking here. Dynamically linking. Okay. Yes. So the JVM takes care of linking to OS library here. Okay. Since Java program, Java program dot class file dynamically yes, linking with OS library by the JVM. Yes, it's independent platform. Yes, it's an independent platform. It is an independent platform. Independent platform. That's the name. Okay, see where our static linking is, exe file is always static linking. That is OS dependent. See Java program and Python both are dynamic linking. Yes, is independent platform here. Independent platform. Okay, so it is statical linking. Yes, if it is statical linking, statically linking, statically linking, statically, statically linking, statically linking, statically linking. Yes, is a OS dependent. Statical linking is a OS dependent, or platform dependent. Platform, platform dependent, platform dependent. Okay, dynamic linking, dynamically, dynamically, dynamical linking, dynamical linking. It's a platform independent, platform. Yes, platform independent, platform independent, platform independent here, platform independent here. Okay, so you get Java program. Yes, dynamical linking with voice library say independent of platform. Okay, fine. Here's some doubt here. See, 1 second. Yes, just let me check his doubt. Vishal, how Java program executes code before it become platform independent? See, okay, now JVM taking tested dot class file, the dot class file linking with voice library. See, before going to link with voice library, first of all, that converts into binary format. So JVM, inside of JVM, there is an interpreter. Inside the JVM, there is an interpreter. The topic we discuss in JVM. Inside of JVM, there is an interpreter. Inside of JVM, there is an interpreter. Inside the JVM, there is an interpreter. That interpreter taking test dot class file, converting into binary format. After converting to binary format, links to voice library, then executes. Interpreter will come to picture. Inside the JVM, there is an interpreter. Inside the JVM, there is an interpreter. Yes, JVM topic we'll discuss separately here. Just 1 second. One second. See, this is JVM. Complete JVM. Inside of JVM, there is the interpreter here. Inside the JVM, there is the interpreter. That interpreter will work on. Yes, JVM topic next we'll discuss. Okay, JVM topic next coming topic. Okay, yes. Now here, so JVM. So depends on with that JVM link changes, right? So JVM is the responsible. JVM is the responsible to make the Java as independent platform. JVM is the responsible to make Java as independent platform. Correct? Now here, very simple doubt here. See, yes, on Windows OS, Windows JVM taking dot class for links to Windows OS library. Linux JVM taking dot class for links to Linux OS library. Yes, Mac JVM taking dot class for links to Mac library. Now question is, JVM is it part of OS? No. JVM is not a part of OS. JVM, yes, is not a part of OS. Part of OS. JVM is not a part of OS. JVM is not a part of it. Then from where JVM care? Then how can you get JVM care? JDK you have to install. Yes, to get a JVM, yes, to get JVM, we should install JDK software. That means Java software. JDK software. So once JDK install, getting JVM. So once JDK install, getting JVM. So to get the JVM, we should install JDK software. So once JDK software installed, getting JVM on Windows OS or getting JVM, yes, on Linux OS, Windows OS, Mac OS, everywhere you have to install JDK software. JVM is not a part of OS. Because the JDK has to install on the different operations. Okay, JDK should be installed here. Okay, right? Next, one more interesting point here. See, Java dot class program. Yes, is an independent of platform. Independent of platform, right? Platform or OS, independent of OS. Okay. Yes. So Java dot class program is an independent of OS, but JVM, yes, JVM is a OS dependent. JVM is a OS dependent. Interesting point, right? Okay. See, Java dot class file is independent of OS. Java program is independent of OS, but JVM is OS dependent. Why? Why JVM is OS dependent here? JVM, yes, JVM. See, JVM developed, JVM developed in C++. JVM developed in C++. That means JVM is a C++ exe. JVM is a C++ exe file. Yes, once exe file, then OS dependent. So this JVM, yeah, this JVM, see here, this JVM Windows based C++ exe file. Yeah, this JVM Linux based C++ exe file. This JVM Mac OS C++ exe file. Okay, JVM is not a part of OS here. JVM from JDK. Yes, so JVM developed in C++, it's a exe file. C++, so JVM is OS dependent here. JVM developed in C++, it's a C++ exe file. It's a OS dependent. Okay, here, what's happened here? Sun Microsystems they have developed developed different JVMs for different operations. Different JVMs for, yes, for different JVMs for, yes, different JVMs, yes, different JVM for different operations, different ways. Okay, so for every ways they have developed Windows JVM for Windows OS, JVM for Linux OS, JVM for Mac OS, JVM for Solaris. For every ways they have developed JVM. Okay, so if Windows JVM, see, Windows JVM can understand about Windows OS library, so that linking here. Okay, next Linux JVM, okay, can understand Linux OS, so linking with Linux OS library here. Okay, Mac JVM can understand Mac library, so that linking with libraries. Okay, JVM is a OS dependent. Sun Microsystems have developed different JVMs for different operations. That's it here. Now here, JDK, about JDK here, JVM is OS dependent, right? Then JDK, is it OS dependent? Suppose Windows system installing Windows JDK, right? That Windows JDK must have Windows JVM. Yes, next Linux JDK must have Linux JVM, right? Okay, so next Mac JDK must have Mac JVM. That means instead of JDK, JVM changing. JVM changing, right? JVM changing. So JDK, instead of JDK, JVM, that JVM changing. Since JVM changes, JDK also changes. Okay, since JVM is OS dependent, JDK also OS dependent. Okay, so for every OS, JVM changing. Since JVM changes, JDK also changes. JVM is a part of JDK. JVM is a part of JDK. Okay, once JDK install, getting JVM. JVM is a part of JDK. JVM is a part of JDK. Okay, yes. So Windows JVM, Windows JDK required. For Linux JVM, Linux JDK required. For Mac JVM, Mac JDK required. So that means same JDK cannot install on different operations. Okay, so JDK is also OS dependent. JDK also OS dependent, OS dependent, OS dependent. See, for example, Windows JDK, C drive in my system, JDK8, it's a Windows JDK. See, JDK Java program files. The Java here installed here. JDK 1.8, yes, here. Bin inside of bin, this is JVM. This is JVM. JVM. JDK, Windows JDK and Windows JVM. Linux JDK, they not Linux JVM. Since JVM changes, JDK also changes. JDK changes, right? So JDK also OS dependent here. Okay, same JDK cannot install on different operations. Same JDK cannot install on different operations. See JDK, let us check the JDK. Let me show the JDK here. Yes, download JDK 1.8. See, from the Oracle Corporation. See this. Oracle, see this. Yes, JD, there are different JDKs. Not only one JDK, right? Suppose JDK is common for everywhere means only one software, but here there are many things. The JDK is here. So this is JDK. JDK, see this. Linux JDKs. This is Linux JDK. Next, this is Mac JDK. This is Solaris JDK. Next, this is Windows JDK. Right? Yes, Windows 10 or 11, last one. Okay. So Windows 10 or 11 OS. That case, this JDK we have to download. Not necessary. You need to download here. It's in Drive. Yes, I have uploaded Drive. Same thing shared here. You need not download here. It's not necessary. To download it, you must have Oracle account. You must create one Oracle account here. That Oracle company account. We should create account, then download it. Not necessary. Not necessary. It's there. Okay. Yes, let me show that. See. Yes, for most of the students, already JDK shared. Still, anyone pending is there? Still, anyone pending is there? Yes, I'll share it now. Still, anyone pending? I'll share it. So this is yes, MNRAP core Java. Here, all the available here. Java JDK 8 is available. Now, presently JDK 8 I'm sharing. Next JDK 9. Next we'll see. First Java 8. Next Java 9. See JDK 8. Next Eclipse and our class documents. Next other material list programs. There are many things are there. Okay. Now initially JDK 8. Next Eclipse and our class doc. These three things you have to download it. These three things. So tomorrow class is JDK installation, Eclipse installation. Tomorrow we'll discuss about Java installation. Tomorrow topic Java installation. So this is this folder, this drive is for all the documents and material softwares. Next another drive for recordings. Recordings drive. Recordings drive. Here recordings. Just a minute. Yes, your match recordings drive. Yes, recordings drive. Yeah. So this is the recordings drive. See, MN the course are new 7:30 p.m. recordings. Last 4 classes recordings. Today class recording also I'll upload. See, by 11 p.m. you can watch it every day. Maximum 11 p.m. not more than that. Okay, by 11 p.m. only I'm sharing every day. Okay, right? See this. Last class recording. Yes, last 4. Yes, already shared with most of the students. Except one or two guys here. For everyone shared. Same thing. Still anyone pending is there? I'll give the access now. I'll talk to online team. I'll give the drive access. Okay. So this is okay. Tomorrow we are going for this installation here. How to install Java. Yes, JDK installation and all that. Tomorrow I'll explain about installations. Okay. Yeah. So this is about yes exe file dot class file. Today class. How Java made us independent platform. Okay. Yes. Here if it is exe file OS dependent reason it links with OS library. Java dot class was an independent platform. Reason it links dynamically. Dynamic linking. Since dynamic linking, that's independent platform. Independent platform. Okay. Exe file dot class for differences. I have prepared. Let me show that. Yeah, this installation topic tomorrow. This is installation topic. Yes, it's installation, Java installation, tomorrow topic. Yes, today topic, exe file. Yes, independent platform. So today, yes, Java features independent platform. Yes, in this here exe file. Exe file dot class. See this, what's the exact difference? See, exe file is a binary code file, right? Dot class is a byte code file. Byte code file. Exe file is a system understandable language. Dot class is JVM understandable language. See main difference. Yes, exe file, it contains program codes, okay, software library and then OS library. Exe file OS library. Yes, dot class, it's a pure Java program byte format. Don't have any OS library. So difference, exe file dot class for main difference here. Exe file contains OS library. Dot class file don't have any OS library. Okay. Yes, exe file is prepared for specific OS for particular OS, but dot class file is not a prepared file. Don't have any OS library. Okay. See, OS library statically linking with exe file. Yes, here OS library dynamically linking with dot class file. That's the difference. Okay. Yes, exe file already prepared one, but dot class file after moving to OS then preparing as per current OS. Okay. See, exe file executes faster than dot class file. Exe file executes faster because already linked. But here, since dot class are preparing at runtime, means linking at runtime slowly executing. That's it here. Okay. So exe file dot class are main difference. Exe file is binary code, dot class a byte code file. Next, exe file contains OS library. So dot class file don't have any OS library. Okay, exe file is a OS dependent. Okay, OS dependent. Exe file is a independent of OS because dynamic linking. Exe file static linking, dot class dynamically. That's the difference. Just remember this. Exe file binary code, dot class byte code. Exe file contains OS library, dot class file don't have OS library. So exe file static linking with yes, static linking with OS library, yes, but dot class file dynamic linking. So it's a difference. Exe file dot class file difference. Okay, so that's all about yes, independent platform. Okay, so next topic. See next topic. Yes, Java installation. Yes, tomorrow I'll explain how to install Java, how to set up Eclipse, Java installation, Eclipse setup, invent variables, how to develop the first application and all that. Tomorrow discuss. Tomorrow setup finishing here. Sunday you getting time here, and Sunday you try to finish installation in your system here. Just utilize Sunday. Okay, tomorrow I'll finish all the installations. Tomorrow I'll finish all the installations here. Okay, Sunday, yes, Sunday you finish. From Monday onwards, programming starts. Tomorrow going for installations. How to install, how to download from your drive and all that tomorrow I'll explain here. Downloading software from your drive. Okay, how to download. Tomorrow I'll explain our installation also. Tomorrow I'll clear. Yeah, that's all for today. Okay, yes, for everyone, software documents shared. Recording also shared here. Still any pending is there? I'll do it now. I'll talk to online team. I'll do it now. Yes, any doubts, guys? Syllabus, huh? Yes, syllabus is there here. 1 second. Do one thing. Go to Durga website. Okay. Durga website. See, course M.N. Rao. 20th Feb started. Yours. This is course contents. This is complete course contents. Same thing as this I'll cover. Nothing missing. As this. Otherwise, I can share. Yes, otherwise I can share in WhatsApp group. No worry. I'll share in the group. Okay. Yes, I'll share in the group. Yes, your syllabus, Java. Yes, yes, course of approach. 3 months, 75 to 78 sessions. Yeah, yeah, this is syllabus. Java 8 features. Okay, fine. This is syllabus. Okay. Yes, today recording also I'll share. Don't worry. Today recording also I'll share in the WhatsApp group as well. In Drive also I'll upload. Yes, you can access from the Drive as well from the group also. Okay. Yeah, that's all. Still any doubts are there? Still any doubts? No doubts, right? If no doubts, let us wind up session for today. Let us wind up. Thank you, guys. Yeah. See you tomorrow.